In this video, we're going to take a look at logarithmic differentiation. All right, this is a pretty common type of problem that you would want to do logarithmic differentiation on. I've got a variable here in the base, and then I've got some variables like the e to the x up here in the exponent. All right, just a real easy way to find the derivative is to use that logarithmic differentiation. All right, so the first thing is we're going to take the natural log of both sides of the equation. So I'm going to go natural log of y is equal to natural log x raised to that e to the x. All right, now at that point, we want to, whatever is over here on this side, we want to apply as many log rules as we can to separate this out and simplify it. Okay, in my class, I call this jumping the frog, but it's basically taking that exponent and pulling it down in front. So natural log of y is equal to an e to the x, all right, times natural log of an x. That's going to make taking the derivative now over here really easy because we've just got a nice little product rule. We are going to be taking the derivative implicitly, so natural log of y, our formula is a u prime over u, so this will be a y prime over a y. All right, now over here we're going to be doing product rule, so I'm going to do e to the x times the derivative of our natural log of x, which is 1 over x. Product rule says then we're going to add. We'll take the next product, natural log of x, times the derivative of our e to the x there, which is going to be e to the x. All right, now in the next step, I think I'm just going to combine this. We'll make it a little bit cleaner. All right, and all in that same step, I need to solve for y prime, so I'm going to go ahead and multiply both sides by y. So I'll multiply by y there, and I will multiply by y over here. That's going to cross out the y's here. So we'll clean up, multiply by y all in the same step. So we'll have a y prime. Cleaning that up, we'll have an e to the x over the x. All right, the only thing I'm going to do to clean this up is take that e to the x and put it in front of that natural log. That way we won't get confused of what we're trying to take the natural log of. We'll put those square brackets in, and then we've got the y here. Now, we want our derivative to be all in terms of x. Right now I've got this y over here, so I'm going to come back up here to the original equation. I know what y is equal. It is equal to this, so I'm going to do a replace. Now, technically, at that point, you have the right answer. How much you have to simplify this, whether you actually have to get common denominators and add there, how much algebraic simplifying you need to do would be dependent upon the teacher that you have, or if you're doing these problems online in an online format, that would also dictate how much simplifying you have to do. All right, but if you get down to here, you replace that y with the x raised to the e to the x. All right, at that point, anybody looking at your work knows that you do know how to do logarithmic differentiation, and really there's no need to simplify that, like I said, unless it's being required of you by your teacher, or it's required because you're doing it in an online format and it wants a certain form for your answer. Definitely, thanks for watching. If the videos are helping, please share with your friends so they can benefit too, and don't forget to subscribe to the channel. Thanks.